Hello, I'm Arda. Today I'm going to talk about image compression using Huffman coding. Firstly, let's look at the meaning of compression. Compression is an operation that is used to decrease the volume of an object physically. Compression in computer data also has a similar goal. However, for computers, the aim of compression is reducing the size of data in terms of bytes. What's more, we are in the data era, so compression is widely used in the data processing and storing. Due to the importance of data processing speed, developing compression and decompression algorithms are crucial for database applications. Depending on the preserving or losing original data, compression algorithms can be divided into lossy and lossless compression. Before jumping up to the project, let's look at the compression algorithm that is used in this project. Huffman encoding technique has been used as a compression and decompression algorithm in this project. It's a lossless compression algorithm that encodes bigger frequency characters with smaller bits and lower frequency characters with bigger bits to decrease the total byte size. Okay, let's look at the project. The aim of this project was developing a Python program that can compress and decompress given text or image with the help of Huffman algorithm. Designing this project was pretty important to understand the logic behind compression. The project contains 6 levels, and in every level I implemented my own solution to develop a fully functional Huffman image compression program. Also, I designed a GUI to test all of the levels easily. After presentation, I will show a demo of my program. Okay, firstly, let's look at level 1. As you can see, I designed a UML class diagram and flowchart to show my work on this level. In this level, I implemented a program that can construct a Huffman tree with the help of a priority queue. Also, I added some methods that encodes the nodes in the Huffman tree and compresses the given text file. For the compression process, I added extra methods to read compressed files and reverse the compression process to obtain the compressed data. Okay, now let's look at level 2 and level 3. I would like to mention them together because the only difference between these two levels is using different image or not. As you can see in UML diagram and flowchart, these levels are a bit different from previous level. In these two levels, I work with images in gray level. Therefore, I converted the gray level image to a 2D image array for use similar methods from the previous level. After that, I implemented the same operation for decompression and compression. However, for level 3, I also used difference image method to compress the given image more. Now, let's look at level 4 and 5. As you can see again, I have a UML diagram and flowchart. However, this time, for compression and decompression operations, I worked with a colored image that contains red, green, and blue components. I already implemented compression and decompression methods for gray level images. Therefore, in order to use these methods while compressing and decompressing, I divided the image into its components and used them like a gray level image. In the end, I merged the components together to obtain the same image again. In level 6, I didn't use additional compressing and decompressing methods. I just designed a GUI that supports all operations in each level. Now I will show you how my Python program works. Okay, let's test some levels on my program. For example, for testing level 1, let's upload a simple text and compress it. It compressed the simple text file. As you can see, it calculated the values. Okay, let's upload its compressed version. I use zip files to create a TD structure, not for compressing more. This file contains the Excel file, that's mean Huffman tree of the text, and the binary coded version of the text file. Okay, let's decompress it. As you can see, they are the same text. Okay, let's try it with the image, for example thumbs up. Let's compress it with level 5. Okay, program compressed. Let's decompress it. It's the same with the text file. This is the same logic. Okay, let's decompress it. As you can see, this is the same file because their difference is 0, and you can see the decompressed version in there. Thanks for watching my presentation. As you can see, all of the levels are functional in my program, so I completed all of the levels.